Okay, is everyone ready? Hi, I'm Hubert. I'm giving a talk about opening garage doors with an iPhone and HackRF. I gave an earlier version of this talk at Ruxmon last year, which a handful of you might have seen. It's pretty much the same talk. I've just added a couple of bits to it. Okay, so about 2 years ago, there was a Kickstarter for an SDR gadget called the HackRF, which looked really interesting. I backed the Kickstarter, and then the device came out, so I had this like cool SDR, and I wasn't really, so I got the thing, but it was just kind of sitting there in the box. So I was wondering, well, I want to do something interesting with it. So I thought, well, what's like a device that I want to that I could look at, that I actually use every day. And so I looked at this garage door opener for my rented apartment. Okay, back to the HackRF. When I backed it, it cost about $400, so a bit expensive. Since then, there was another project called HackRF Blue, which was on Indiegogo, which made a cheaper run of them. That sold out, but there's now another one starting up. You can sign up on this website to be notified to get another cheaper version of it. It's just they're targeting $150 US. So yeah, so the basic idea behind my talk and what I did was, so I have this this remote here. I've got a HackRF, and I wanted to do something cool with it. So I thought, well, is there some way I could like clone this or somehow make it so that I could use my iPhone to open my garage door? So I don't know, just kind of do something fun with it. And just to, so this is the end result, just to skip to the interesting part. So in the end, I did manage to make an iPhone app which opened my garage door. And then basically the rest of the talk is just explaining what I did to get to that stage. Okay, so starting with just looking at the remote that I got with my apartment, looks like this. You know, just by looking at it, it says Merlin on it. I Googled the company. It turns out they're like an Australian company that makes garage door openers and remote keyless entry systems. Just the website already gave me some helpful details. Like it said, it uses 433.92 megahertz as the frequency and encryption rolling. So sounds like it should be secure or interesting. This is still from the manufacturer's site. Yeah, mentions rolling code receiver. Doesn't give a great amount of technical detail, but yeah, it mentions rolling encryption implies it's supposed to be secure. So then I Googled a bit more, just just Googling Merlin remote, and I saw that there's third-party sites like on Alibaba selling keys that can supposedly clone these remotes somehow. Again, didn't really give you any details about how exactly it does that. Yeah, this is a YouTube video from these clone remotes. Music. Yeah. I'm actually not sure whether this device actually would just clone the key. I actually don't think it does. I think all this done is basically make aftermarket keys that you can use if you have access to the base station. So anyway, so in order to figure out how to use GNU Radio a bit and how to do something with the HackRF, I looked at this series of tutorials that Michael Osman made, which are quite helpful. Mike Osman is the guy that actually designed the HackRF and brought it out, and he's published this series of videos just to just kind of walks you through some basic examples of how to do stuff with GNU Radio, which is kind of very daunting at first because it's kind of it's not a very easy to use application. Just to give you a flavor for what these videos are like. So here's Mike Osman talking about how to build a basic flow graph in GNU Radio that's just used to receive normal FM radio. Yeah, so it just kind of it's quite like I started just knowing absolutely nothing about how to drive GNU Radio. So just going through those videos, starting from the basic example, it was quite helpful just to kind of learn the basics of like how do I do anything with GNU Radio. So starting off, I knew from the data sheet that the remote's on 4 33.92 megahertz. So I just used the command line utilities that come with the HackRF to record the radio transmission to a file when I press the button on the remote. And yeah, it just looks like that. You end up with a file of a couple of megabytes. So it's about, at that sample rate, the file grows at about 8 megaseconds. So the files can get quite big. So then you end up with just the file. So what I do with that. So then a popular tool to analyze IQ files that you record in this way is Borderline. So you enter some parameters, load the file, and it gives you this visualization. And you can kind of see there's a hint that, there's like a shift in the frequency of the transmission, and it kind of gives you a hint that that's the ones and zeros that the remote is transmitting. So something that came out since I did the talk last year, there's something called the Porter Pack, which is like an add-on module for the HackRF. It's this little, normally HackRF is just a sealed black box, but you take half of the box off and stick on this extra module here. And it's basically a touch-capable LCD display and this controller here, and it's got a firmware on it that lets you record transmissions while you're out in the field to an SD card that you insert here, and it gives you kind of Borderline-style analyzer as well. So I didn't have this available when I did this last year, so but it's kind of cool. It's still in development, so the guy that released the Porter Pack is still working on the firmware. So he's only just released an updated version of the Porter Pack firmware that lets you record to SD card, but like it doesn't do transmitting from SD card yet. But it's kind of interesting. That's something to watch. Moving on. So the setup I used when I looked at this initially is native Ubuntu Linux with GNU Radio installed from PyBombs. And yeah, just to give you an idea of what that give you an idea of what that looked like. Just had my native Linux machine here, the remote, HackRF there. Press the button, and I had stuff set up, the flow graph set up in GNU Radio that would analyze the transmission in real time and show me that. So you can kind of see there that like the spike in the frequency was kind of moving side to side. So again, that's just a different representation of the ones and zeros that the remote is sending. So I started out with this. As my source in GNU Radio, I used the IQ file that I recorded with the command line HackRF utility. Convert that from UChar to floats to floating point numbers. Deinterleave that. Convert it back to complex numbers, add a constant to like offset it, throw the sample rate. To be honest, I don't totally understand what each of these blocks does, but basically you just add these elements together and then you end up with what I just showed in the video. You end up with a little graph that shows you the transmission. So basically the next mission, probably the hardest part of the whole thing, is basically just getting GNU Radio to somehow make sense of the raw data that you've recorded. So you've got to turn that like 50 megabyte file, which only represents a couple of seconds of a broadcast, back into some binary format that you can then process with another tool to actually analyze the bits and bytes that are in the transmission. And that was really the hardest part of the whole thing. So just basically trying to add blocks to GNU Radio, trying to tweak the settings to get it to decode stuff. Here's another video. So yeah, I found this, I didn't, at least last year when I looked into this, like there wasn't a whole lot of like tutorials or how-tos that really explain you how to do this. So I found this one blog post where a guy analyzed some like alarm system remote, and it gave me some hints for how to do it. Basically, you just end up adding a number of filters, and then you try and filter the signal and convert it so that you end up with kind of a WAV file that shows the 1-0 transitions very clearly. And so then I eventually ended up with this, where I have ultimately a sync here, which is after going through number of filters, clock recovery, the binary slicer, I end up with a sync here, which is like a raw binary file that has ones and zeros in it, representing the 1 and 0 symbols in the file. But the 1 and 0 symbols are still not the actual bytes that the remote is sending. So there's one more level of decoding that you have to do. And I did that. I probably could have done that part in GNU Radio as well. But I just, for ease of use, and because I don't know GNU Radio that well, I did it in the Python script. So basically, the encoding scheme that the remote uses, which you could find in a data sheet, is this. So a logic 0 is like 2 highs and a low, and a logic 1 is 1 followed by 2 zeros. So I just, using the raw file that I make GNU Radio output, I then made a Python script which just does exactly that. So 0 is 1, 0, 1 is 1, 0. And then I finally have the bits and bytes that I want in the context of my Python script, and then I can get output like this. So it's kind of starting to make sense. So you can see that there's like kind of 3 sections to the output every time you press a button. And as long as you hold the button pressed, that transmission is repeated continuously many times. The code doesn't change, though, until you sort of let go of the button and press it again. So the thing at the start is like the rolling code, so like scrambled bit. You don't know how that's worked out. And the thing in the middle seems to be like a fixed serial number, which is like your key. And then I think the bit at the end is like the operation. So I think it's like 1 is open, which is the big button, and then 6 is the smaller button, which closes the gate. So yeah, this is kind of starting to make sense. Like I finally at a stage where I've got like I can actually interpret the data that the key is sending. So okay, so coming into this, I thought, well, yeah, sure, it's just going to be something really shit. Like it's just going to be like I'll just replay 1 key, or maybe I thought maybe the key space would be so small that I can like brute force it or something. But actually, it wasn't that trivial. And basically, when I recorded just 1 key press and replayed that, it just didn't work. Like it just nothing happened. The door didn't open. So I thought, okay, well, maybe I can't like hack it after all. But so then I did some more Googling, and I found out that this uses like quite a well-known chipset called Keylock by Microchip, which is implemented by many manufacturers and many different kinds of keys. And it's kind of like, it's not completely crap. Like it's basically has there's like a counter which is on the key, and a corresponding counter on the base station. And every time you press the button on the remote, it basically takes that counter value and encrypts it with a key that only the base station has, and then basically the base station sees the serial number of your key, and it decrypts the encrypted part of the transmission, and it gets the sequence number from that, and supposedly it then checks, if the sequence number is the next number in the sequence, it lets you in. But if you're just repeating a transmission that you've recorded, the sequence number will be the same, so it won't open the door, it won't let you in. So in theory, it's kind of okay. So there has been research into this a couple of years ago. This German team did quite advanced attacks on these remotes to actually recover given physical access to the key, recovering the secret key from the remote, which is kind of more advanced and then not really the angle I was looking at, but it was kind of interesting. Like they sort of had a nice explanation here of how the scheme actually works, and this diagram here, like that, you have these 3 segments that kind of made sense and corresponded with what I saw when I decoded the transmissions from my one. So another little thing that I noticed is so one problem I had is like I wanted to capture many transmissions from the key, so I had to press the button. But like where my desk is, there's actually still in range of the door, and it's kind of like I don't want to annoy my neighbors like constantly opening the garage door. So I actually worked out that you always hear about tinfoil, like box radio, like I've never tried this before, but it actually works. So if I just wrapping some tinfoil around the key and holding that next to the antenna, I could still record the transmission fine with the HackRF, but it actually blocked it and it didn't open the garage door, so I could avoid annoying my neighbors. So then after like messing around for ages, and basically I spent a lot of time just getting to the point of being able to decode the transmission. That took me ages, but I still hadn't really like, I hadn't found anything that would let me in any way like hack it or do anything really, because yeah, I could decode the transmissions, but if I replay them, it just didn't work. So then I actually noticed, hold on, if I, rather than just recording like one button press, if I record several button presses in a row, it actually worked. Like, that's all I had to do. So just, I recorded me pressing the open button like 5 times in a row and replayed that, and it worked every single time. So I thought, oh, hold on, like, surely that's not supposed to work, because it's like, based on how the scheme's described in other sources, that isn't supposed to work, because once the counter for your key is incremented on the base station, it shouldn't accept numbers that have already been used. So yeah. So anyway, so then that's kind of, just to get to the original aim was I want to make something that lets me open with my iPhone. So just as an aside, I quickly just hacked this thing. So I made a basic web server in Python that just sits there and then executes the HackRF transmit script. And I made a basic iPhone app just with a button that does an HTTP request, just so that I had something to show for the presentation last year, basically. And yeah, then just another quick demo. So all this is doing is I made the iPhone app. I even put the fingerprint biometric stuff into it, so only I can open the door. And all that's doing is it's still on my Wi-Fi from inside my flat, and it's just calling the HackRF transmit script to replay that transmission of me pressing the open button 5 times. That's all it's doing. So I kind of achieved the goal, but like I didn't really do any sort of clever hack, to be honest. I just realized that, oh, hold on, like if I just record multiple transmissions in a row, it works. So yeah, so the summary of my findings about this key system does check the rolling codes, so they're not lying when they say they have rolling code security. You can't clone the key into a simple static transmitter that sends the exact same code every time. But turns out, like after I didn't even need like 5 presses. It turns out that if you just replay at least 2 codes with in ascending sequence, it works every single time. So my theory about why this works is that basically the receiver keeps a list of expected counter values, E for each key. When it receives a counter value from the key, N, that is below E, it resets the expected value. And then as soon as it receives a counter value N that is equal to the expected number plus 1, it opens the door. So I think the flaw is that the base is happy to reset the expected number. That's just my working theory. I don't know if this is exactly why it is, but it kind of would explain the behavior that I'm seeing. So yeah, just saying again, that's what the bug seems to be. And the interesting thing is, so this microchip key lock chipset is actually quite widely used. There's a lot of remotes that use it. And I actually spoke to like Mike Osman and Sammy Kamka on IRC, and they said like, oh, that's really strange, because like they've messed around with other key lock remotes, and like the ones they looked at, it does properly enforce the like ascending key thing, and with their ones, it just doesn't. Doing this just doesn't work. So I'm not sure why this works. So I'm guessing maybe it's just that the Australian company that's integrated the keylock chip has done some customization, or has just, I don't know, built a vulnerability into it somehow for mistakenly. Skip that. Yeah, that's what the thing looks like by the garage door. Future work that I want to look into. So it's kind of a bit ridiculous to use a like $300 HackRF as a transmitter just to open your garage door. Like it's obviously not it's useful to research it, but it's not really practical to dedicate an expensive piece of equipment like that just to open your garage door. So if I actually wanted to practically set something up that I can just leave there, it would make sense to use like a cheap little transmitter. And I actually bought one. I just haven't got around to like doing it yet. You can get this little board that's popular for Arduino projects. They're literally like $2 including delivery on eBay. And you can directly drive that from a MicroPython or Arduino Uno board with no other components. And that should be exactly the type of 433 megahertz transmitter that this uses. So it should literally be a question of taking the decoded bytes that my Python script is giving me already and just making the microcontroller send those bits to the transmitter, and that should work in theory. So then you could set up a really cheap box that you leave in your house and then hook that up to your smartphone via to the cloud or whatever. Other interesting things to look at with the Porter Pack. There's another guy who started a fork of the Porter Pack firmware where he's aiming to implement some interesting features, like for example POXAC pager decoding, and so potentially it might be possible to implement this as part of the Porter Pack firmware as well. So rather than having to just replay it, you could just maybe save the actual couple of bytes that you need to send and get the Porter Pack firmware to generate the signal and send it. That's it. Questions?
So with the Goldenberg team, saying that if you capture two or with a bit of increment of the polling process counter, you could replay that one capture multiple times and work each time.
That's what I found.
So the receiver is willing to decrement or to decrease.
Yeah, that's my working theory. Yeah. Okay. So it's like so replaying one never works, or replaying them in reverse order never works. Yeah. But if you have any capture with at least two presses in sequence, it works. So I actually just played around with it again last night just to make sure that I'm not talking crap. But I made two separate captures. Like I recorded one IQ file with just one press, recorded another IQ file with subsequent press, and just manually, like on the command line, they can even be quite like a couple of seconds apart. They don't even have to be, So it seems to me that there's the issue with the base is that it appears to, when it receives a code where the sequence number is below what it should be, it doesn't open it straight away, but it resets the expected code. And then you just send the subsequent number and it opens.
I think it's because it has to accept any code in the future in its buffer. Because if you accidentally push the button in your pocket,
but in order to support that, you don't have to support older codes. You don't have to support codes that are in the future.
Yeah, but the end rolls back around the start.
True, but
so it doesn't know how many times you set on the button. As long as it gets a sequence in order.
Yeah. Sure, like I don't know how big the counter is, so assuming it's like 16-bit or something, you need 65,000. So
I think there's only 256,000 codes.
Yeah, I don't know. I mean that's I don't actually, you can't actually see what the sequence number is because that's part of the encrypted like 30-bit section. So just going back to so it's gone too far. Yeah, I don't know how big the counter is, but like I said, speaking to a couple of other people who've played with this, they say that they've definitely tried this after I mentioned it, and they said, no, it doesn't work for me. So it does seem like it's some kind of unique implementation flaw of how these people have implemented QOP. So I don't know how big that counter is, and yeah, you obviously do have to deal with the overflow somehow, but I don't know. I mean, you could still be smart about it and like say you would only accept a lower value if you know that the current counter is about to overflow, for example.
I don't know how many times they push the button. Because if you set on it,
Sure. But I mean, if the counter is big, then you would expect that it's pretty unlikely that you would press it like 65,000 times to get that high. So yeah, I don't know. Yeah, you're right. Like that's an issue they would have to deal with, but the way they've definitely got no protection at all against this kind of basic attack. Yeah.
Their older models much worse.
No, I actually didn't. Sorry, I can't really be bothered with the kind of disclosure shit fight. Like it's just, especially with this kind of hardware manufacturer, I think there might be like quite hostile to it, or either you'd either end up getting like threatened, or they would just ignore you, or because it's not really practical for them to patch. Like there's probably like 1 million of these like out there in Australia, and they're not going to send people around updating the firmware for this thing.
That's what cars are inheritance.
Yeah.
You're saying the serial number is broadcast.
Yeah.
So serial number is broadcast at each time you hit. Is the actual code connected or generated with the serial number, or is the serial number used for authentication, and then the code set?
So the serial number is plain text, so you can see that's the middle bit, so I'm guessing the way it works is the base maintains a list of the counter values that it expects from different keys. So yeah, that's what it, and also it's for authentication. So you might have a system where certain keys are allowed to open certain doors, and there might be some kind of central database involved. So yeah, so
I guess one question I have is, if you were to hypothetically capture the serial number of the adjoining apartments, send their serial number to your secret code, you see if the actual code is related to the actual apartment, or it's just a universal. I
haven't tried that, but I would expect that it would be tied to the particular key. Because it's got to, it kind of has to be, because it's got to track the expected counter value for different keys. So yeah, I reckon it probably is. Yeah. Okay. Yeah, makes sense. Yeah, you're right. Yeah, I'd have to borrow my neighbor's key.
Does anyone know where the code is stored?
You don't need to try the kit, you just need to try the serial numbers.
Yeah, but it's probably not really easy to enforce. Yeah.
So that's the 3 packets of HackRF. Is that correct?
Yeah. So basically, it keeps transmitting. If I just like press it.
Which is the set sequence then.
Yeah. So I mean, just so as long as you press it, it keeps transmitting. So and it keeps repeating the same code. So it does keep continuously transmitting, but it's the same number over and over. And then if you press it again, then after basically when you let go, it increments.
When you start to transmit, you send just one of the whole.
I did try that, and that doesn't work. So what I found, that's the first thing I tried. So initially I just recorded one press, replayed that, never worked. But then I eventually realized that if I just record like 2 or 3 in a row and replay that whole sequence, it works every time.
Do you replay it with a whole button with multiple packets in it, or do you just?
Yeah, I mean I've replayed it. I tried replaying recordings where I'm just holding it for one button press for a long time, and yeah, that's. So it definitely is enforcing a rolling code in some way, but the flaw just seems to be that it's having to reset the expected value.
Two questions. So what happens if there's a new tenant or someone loses?
I don't know. So they can. There is some procedure whereby you can take a blank key and you press a button on the base, and it does something. To enroll it. So yeah, I think basically the way it works roughly is you press a button to register a new key on the base. You press a button and then the base learns the serial number of the new key, and it's also somehow able to decrypt the encrypted section to get the current count on that key, and yeah, so then it registers it. And yeah, I mean, if somebody loses a key, then I suppose on the base they can say you just delete that entry, so then that key will no longer work for that serial number.
So that's exactly it. So the shared secret might be line-based.
Yeah, I don't know. I mean, so there's actually like a data sheets and like analysis of key lock in this talk. So if you Google this talk, they released their slide deck for this talk as well, and it talks in some detail about how exactly it works. And yeah, but basically according to their talk, but they don't mention this basic flaw. So yeah, talking to some other guys, like it seems like keylock by itself doesn't necessarily have this flaw. It's just this implementation for some reason has this flaw. Maybe, yeah, I don't know.
Those things are never updated. So,
Yeah.
Playing an attempted SQL retry, you have to press twice.
I kind of got that impression initially, but I'm actually not sure. It's kind of hard to say because, yeah, like that would kind of make sense because then that would make sense if it like has to reset it and then ignore that first thing. Yeah. Yeah, I'm not entirely sure. Yeah.
because do you have any interest in doing this? Like, we had a robot just push the button for a week and a half to figure out when that problem.
Yeah.
It depends how much you can.
Yeah, no, I mean, yeah, you could do that, but to be honest, you need to you can't really tell if the code rolls over. Like you'd have to extract the secret key that's needed to actually decode the encrypted section. So you don't even know when it rolls over. So yeah, I think there is some shared key that it uses to decrypt the encrypted section of the thing. And if you can work out that key, then you can just decrypt what's inside, and you can see what the counter is. So then you know when it will roll over. But yeah.
So it will save from this experiment again used to open cars.
I guess, I mean, I haven't tried, but I'm pretty sure that most RF-based car remotes, they're like better systems, and I think they're bidirectional as well, whereas this isn't. So yeah, I mean, sure, you could apply the basic methodology to try and analyze car keys, but I'm pretty sure that any modern car on the market wouldn't be vulnerable to something as simple as this. But having said that, Silvio did a talk where it did exactly that. Was it a Honda or a Toyota? It was an older Toyota or something. So a friend of mine, Silvio, did a talk at RuxCon 1 or 2 years ago. That talk as well. Yeah. And he found that it was either Toyota or Honda, and it's like an older model, like early 90s vintage or something, where he found that was it brute forcing or what he did or
Yeah, he was using captures.
yeah. Basically, yeah, he did a similar thing, just looking at keys from this old Japanese car, and he found some flaw where, where it's something similar, where he was able to open the car and shoot it. But presumably it doesn't have the same flaw, I would hope. Yeah, who knows?
Okay.
All right, thanks. Cheers.